Hi, everyone. Thanks for coming. So let's get started.
This art was created by a machine. This music was created by a machine. And, of course, this voiceover was created by a machine as well.
We'll find out if I'm able to use a handheld mic. I haven't done that in a while. So you guys tell me if you stop hearing me. I haven't entirely too many things to cover in half an hour, so I'm going to talk really quickly, and we're going to do a super quick intro to begin with. So my name is Sasha Rosenbaum. I grew up in Europe. I live in the US. I work for Microsoft, and I've been building things with technology for quite a while now. So before we get started, I just want to do a couple of definitions so we level set what we're actually talking about here. So the first thing that's important to define is intelligence. So intelligence is usually defined as the ability to accomplish complex goals. And then we can progress into artificial intelligence, which is usually defined as the ability of a machine to perform tasks commonly associated with human intelligence, right? So whenever a machine is able to do something that's considered to only be accomplishable by humans and complex, we call it artificial intelligence. And then one related term is machine learning, which is a science of getting computers to act without being explicitly programmed. Okay, so not all artificial intelligence in the world is based on machine learning or deep learning or things like that, but a lot of these algorithms are based on machine learning. So, which means that they're not being programmed by a programmer that is explicitly defining the rules of action for the machine, right? We're just learning from ingesting a bunch of labeled data, recognizing patterns in that data, and then being able to predict correct labels for new data, for new input that we're going to ingest, right? So this is kind of the base definitions of stuff. And then, so help me conduct an experiment here. Everybody who's able to stand up, can you please stand up? Thank you. And then can you please touch your nose with your right hand? All right, you guys are completely awesome. So now I need just one of you, and you can sit down if you want. I need just one volunteer to explain to me exactly how you did it. So how did you understand the language, and then how did your mind command your body to do exactly the action that you've done so many times, and what exactly muscles fired when you did it? So the truth is we usually don't know how we do this, right? When I came up on this stage, I correctly estimated the level of the step that I need to make, and I don't really know how I did it. And neither does this guy. So this is a video of computer simulation, learning to walk, obviously facing some obstacles, right? So this is how AIs actually learn new things right now. And so they learn in a way similarly to how a child learns, right? So they basically face problems and then find solutions for those problems and then get better and better with time. And a lot of this is basically black box to us as well, right? So one more definition before I go on. So superhuman artificial general intelligence is defined as the ability of a machine to accomplish any goal as well or better than humans do, right? And then there's a lot of opinions out there on when superhuman intelligence is going to be achieved, if at any time it's even possible, right? So it's the research community, right? So people who spend their entire lives working on this problem, some of them say that we'll never be able to achieve superhuman general intelligence because it's just a very difficult problem to solve. Some of them say, okay, superhuman intelligence, general intelligence, is going to be achieved within like by 2030 or 2050 or things like that, right? So it's really, really close. Let's all panic now. Or not, depending on how you look at things. But one of the things that researchers say is that information and computation are substrate independent. So you don't need to be carbon-based life to be able to perform intelligent actions, to learn, to store information, and so on. So, and another thing that is opinion widely had out there is that we only need to worry about conscious machines, because the conscious machines is where you become, they may become evil and like try to take over the world and stuff like that. And of course, there's also the view commonly held by Hollywood producers, which is the humanoid robots are going to take over the world and put us all in the Matrix or whatever, which is the least of the things that we need to worry about when it comes to AI. But okay, just because it's difficult for many reasons, and it's also not the most likely scenario. And you also don't need to be able to physically resemble a human to, perform actions. And another thing that's important to note is that goal does not equal purpose. So machines don't actually need to be conscious to make actions, right? So if you are talking about a heat-seeking missile, it doesn't really have a purpose. It doesn't really have consciousness, and it doesn't really have any type of general intelligence, but it does have a goal, and it's really capable of accomplishing the goal, which is its target. And if you happen to be near that target, then you have a huge problem. Now, it really isn't going to help you to know that this missile doesn't really care about you and isn't really actively seeking to harm you, right? So what we need to worry about is what machines do, not what machines choose to do. So this is a drastic example, right? But really, for a machine to harm you, it doesn't need to actively seek to harm you. It just needs to not care that it's harming you. Okay, so less bleak things maybe? I don't know. Another question is, does artificial intelligence really need to be that smart? So people who talk about superhuman general intelligence not being achievable, is that really the thing that we need to worry about? Because so right now what we have in terms of artificial intelligence are things that are accomplishing very narrow tasks. So most of the algorithms out there can only do one thing, right? And it's usually one skill that is accomplishable by humans. So I have to give this example, right? Obviously, this was 97. In 96, Kasparov said, a computer is never going to win a chess match against a human. In 97, a computer won a chess match against a human. And obviously, this happened recently. I think it was 2015. That computer also won in Go, which is a Chinese game, a Chinese board strategy game, against a 18 times world champion. And it won by using a strategy that was never used by humans that it learned from. So it was interesting like that. Now, more relevant to everyday tasks that we're talking about, so Microsoft, this was recent, we surpassed human parity in translating from Chinese to English. So we can do it as well or better than humans. We also can do speech to text as well or better than humans. That was a couple of years ago. So now all of the subtitles for talks and stuff like that is being done by an AI, and it's being done really well. Okay. And of course, we tend to think that things that are easy for us should be easy for a machine and vice versa, but of course that's not true. And so a lot of people dismissed computer intelligence because they said, okay, we're really good at recognizing faces and computers are really bad at it. That means that computers will never be able to accomplish certain things. But of course, many of your phones and my computer are unlocked by a facial recognition algorithm, right? And that happened, and that used to be considered very difficult just 15 years ago. So, of course, this is not your job, right, to recognize faces. I mean, it is part of your job, and it's important, but it's not the bulk of it. But these things have real implications. So in many of the food chains in the U.S., the drive-throughs are now like people are considering putting machines in there because again we surpass speech to text with machines. So now we can do this better than humans. So all of the misunderstood orders are less likely to be misunderstood with a machine, and it also gets paid a lot less. So we also have all sorts of virtual dealers, and in casinos, if you're ever in Vegas, you will notice that some tables are now manned by sort of like a video guide. There's also, this is actually happening in a lot of chains as well, retail chains. So they're working on replacing humans with this or another way of automation. Doesn't have to look like this. It can look in many different ways, but it actually remembers inventory pretty much better than humans. So, you know, there's that. And of course, a lot of times we're even able to tell if we're speaking to a human because so much of our interactions are done through text or web interfaces that really this becomes almost transparent if somebody looks like human as long as they interact with us in a similar way. And of course, if you're missing someone that looks like human, this is Micah. She was unveiled by Magic Leap recently. She's fully AI-based. She lives in virtual reality. She can make eye contact and react to your facial expressions and look totally like a human. Now, this is all great, but these are all narrow systems, right? So maybe we shouldn't worry about it. So this is the likelihood of computerization. This was a study done recently by an Oxford University researchers. So if you will notice that clerks, cashiers, cooks, drivers, bakers, waiters, and accountants, auditors, paralegals, and stuff like that, those people have 80 to 90%, maybe up to 100 sometimes, percent likelihood of automation, right? And now, if you look at Bureau of Labor Statistics for the United States, I don't have that for the UK, but I assume that's kind of similar. So over 15 million people are in sales occupations, so retailers, again, cashiers, sales reps, and stuff like that. Millions of people are waiters. Millions of people work for, auditing and stuff like that. So you notice a lot of overlap between these professions and the things that are likely to be computerized in the next couple of decades. So even if it doesn't touch your particular job, I think we have a little bit of a problem here. But it also kind of does touch our particular jobs, of course. So one of the things that is out there, this is just a few projects, and they're in initial stages. They're kind of just starting out. So this is all pretty new, but this is happening right now. So Deep Code learns from open source projects, so everything that's out there on GitHub and the like, and then it analyzes your code and sort of like Grammarly for code, right? So it warns you if you are doing something that's anti-pattern or has like a security concern or stuff like that. Then this is a feature called Azure Advisor. It does a lot of things, makes recommendations based on machine learning. But one of the things that it does is it tells you where to index your databases. So we had a lot of clients basically resolve their performance issues on their databases guided by recommendations of Azure Advisor. So basically, this job is a big part of a job that is called DBA. These people used to be paid a lot of money. If I were them, I would be searching for a new job right now. So this is, I don't actually know how to pronounce this company name, UiZar, I think. Basically, these guys scan mockups and wireframes, and they generate HTML and CSS from these mockups and wireframes and do it pretty well. This is another IT job that is called a front-end designer. It usually took, a few days per wireframe. Now it can potentially take minutes. So that's another thing automated away. And then, of course, this was just a year or two ago, Microsoft, in collaboration with Cambridge University, we did something similar to Deep Code. It's called Deep Coder. And it learns from the open source code out there from samples, and then it's able to solve simple simple programming challenges, so things that they do at competitions. So again, right now it's doing something at the level of like newbie developers, But that is not to say that a couple of years from now, it won't be able to program on a much larger scale. Now, when it's able to program, I'm actually going to be worried about my job too, right? Because this thing doesn't sleep. It does not require coffee. And it generally is highly available and can be deployed to multiple machines and, scaled out, and computation is cheap and all of that. So, and it also doesn't forget about best practices, and standards become real for that thing, and it's actually aware of all the security vulnerabilities out there. So it's actually probably going to do a better job than I ever did. So, okay. You should read the entire quote. No? Hans Moravec said this a number of years ago. So if you imagine the landscape of human competence as sort of like a landscape with mountains and valleys and stuff, and you imagine like computers gaining certain skills, that you can see this as water flooding the landscape. So gradually it surpasses human parity in different skills, and we sit on mountaintops and we feel pretty safe right there, but eventually, inevitably, all of this is going to be flooded. So, another thing. So I'm super happy that Neil talked about exponential progress being not intuitive, because that's one of the points that is important to make here. Because so our rate of progress is exponential right now, right? And everybody knows that we're doubling the computational power available to us every year, right? But that also enables us to double the computational power the next year, because we're using the better technology to develop even better technology. We're also using the internet to share knowledge of everybody. So people used to develop the same thing in different corners of the world, right? Now I can be in China and collaborate with somebody in Sweden, and this can be the best researchers in the world sharing the most advanced knowledge available out there. So when you look, so humans intuitively think that the progress is linear, right? So what happened last year is exactly what's going to happen next year. But when you talk about exponential progress, it looks something like this. This is the only GIF I found for this. So this is bacteria replicating. Yay. So basically, at first, it looks like it's really slow, and it looks like it's being linear. But then at some point, it reaches an inflection point, and it gets crazy, right? It just floods you, and it looks as if it reached an asymptotic point and just going straight up, right? So if we're talking about the rate of adoption, so this is a famous example. This is Fifth Avenue in New York. This was 1900s. There's a single car out there, and everything else is horses. And this is 1913, and this is Fifth Avenue in New York, and there's a single horse somewhere in there. I can't even see it. So this was 13 years, and this was a century ago. So right now, if someone developed a computer that can develop code, guess what the rate of adoption of that thing would be? Yeah. Okay. So what do we do now? The thing is, so despite all of this, I'm not actually trying to scare you. I'm just trying to make people aware, because I think we're not thinking about the change that is happening. So we keep talking about, stuff that is very menial, that's, on the news today, and we don't realize that this major thing is taking place. So the first rule, though, is, of course, don't panic. Because, so the biggest reason for not banking, well, one, it doesn't help, but it also, we're really bad at predicting the future. We always make mistakes when we try to predict the future. So we actually don't know what's going to happen. It may be that someone will develop something major, breakthroughs, in the next couple of years, and it may be that it will take 100 years for anything to change, and it may be that we'll, all going to die from a different event and won't matter. I know, yeah, okay. This wasn't planned. So one of the things that we could do is we could oppose progress, which is, it's a really bad idea, even selfishly speaking. And so I'm going to give just one example for why it's a bad idea, but there's actually lots of examples for that. So let's talk about, ooh, that's the wrong slide, sorry. Okay, this is the right slide. So the pension problem. So a lot of people think that the pensions problem is about like people not saving enough money, or government not printing enough currency, or maybe even resources running out on us. But there's actually one more problem that is a problem with aging population, which is happening right now around the world, right? And that is that we have a certain rate of production. So let's imagine an island economy, okay? And let's say I'm on the island and I have a person to support, so I'm supporting that person. Okay, I planted a garden, so I increased my rate from hunter and gatherer rate, right? So now I'm doing it much faster. I'm able to support one more person. Okay, this is great. So let's introduce currency into this economy. So let's say there's one more person on the island, and I have some type of currency that this person cares about. Okay, that's cool. Now I give him the currency. He gives me the resources. This is great. We're able to support 2 more people. Awesome. Okay, now we can introduce tools into this. This is great. Let's say the tools have really improved my production rate, so now we're looking at more people. Let's spread the tools. Okay, more people. Now we're at 24 hours of capacity, and we're working as fast as we can, and we're utilizing all of the resources and all the available tools that we have. So now, if we potentially had more people to feed, we would have a problem because they would starve. Right? So if we look at the aging population rate around the world, we can see that a lot of folks don't have enough of the new generation to feed the old generation. And again, not a currency problem, more of a production rate problem. And the only way to solve this is actually to improve our tools to increase the rate of productivity, right? So either that's an AI-powered tool that can work faster, or we can develop some sort of innovation to enable us to produce more resources that can be used, right? Now, I said this was not the only problem I need to care about, right? Obviously, we need to care about global warming. We need to care about potentially asteroids hitting Earth. There's a lot of things that we don't have a solution for right now as humans, and the only way we're going to be able to solve it is by using advanced technology. So stopping the technology progress rate is actually a bad idea, even if we don't like it. So I'm going to go back, and this is going to be terrible because we had the wrong slide. Okay. So the jobs that are going to linger, and this is also based on some studies out there, are the jobs that require creative intelligence, so basically unpredictable situations that you need to react, right? Because machines are still, our AI algorithms are still pretty bad at anticipating change that comes in an unstructured situation. Social intelligence, so things like teaching small kids, is still very hard to do for a machine. And then perception and manipulation, including physical dexterity, so things like nursing, it's really hard to replace by a machine. So if we look at that other opposite side of that table that we talked about in the Oxford study about the job replacement, we have therapists of various kinds. The percentage ranges are because there's different kinds of engineers, so you can see it goes from 0.4% to 96% of likelihood, but you can read the entire study online. The good news is software developers and engineers and scientists are about the last people to be replaced. So we still have a few years. But in general, this is just anything that involves unpredictable situations. Now we're having this problem again. Okay. Yay, cool. Okay, so one last thing that I wanted to talk about is AI ethics, because right now, all of you are building systems. Each and every one of you is building systems that potentially are influencing millions of people around the world, right? Everybody is responsible in this room for a rate of innovation. And AIs are increasingly deciding things around us. So AIs are deciding, if you're likely to commit a crime. And AIs are deciding if you should get an advertisement for a job. And AIs are deciding let's say if you were getting approved for that mortgage that you have. So these AIs need to be built responsibly. And the thing about it is a lot of people think that bias is a property of humans, but bias is actually a property of information because the world is vast and unpredictable. So to be able to make sense of it and make decisions, we need to generalize and we need to have pattern recognition. And like we said, ML algorithms work by pattern recognition. So guess what? If you ask an ML algorithm and you don't actually consider anything other than that, it will say that the ability to predict the murder rate is highly associated with zip code or maybe with your race, right? So again, we have many, many examples of people out there. So I'm not going to read through those, but basically AIs that are in use today that are, for instance, discriminating against women in terms of advanced IT jobs, or discriminating against people and minorities and people of color in terms of their likelihood to commit a crime and things like that. And this happens right now, right? So we are building the algorithms that decide on her future, and we need to make sure that we are building them responsibly. Because again, AIs don't necessarily have a moral compass, and we don't necessarily know what goes into that decision making because a lot of this is a black box, right? So build AIs responsibly. And apparently I speed up as usual, so we can actually take questions.
So we've got time for a couple of questions, if anyone has any.
Hold on. I can't hear you.
Yeah, I was going to ask, it's great that you're giving a talk like this to people with a technical background, and some of this information you've given us are things that I'm, in terms of positives, were things that I'm maybe not aware of. But what are companies like Microsoft doing to reach the general public, people that have sort of a greater sense of apprehension about AI, the sort of negative connotations that the media portrays about AI, that kind of thing? What are companies like Microsoft doing to reach out to people like that, to reassure them that actually it's not all bad?
So I don't know in particular if we're doing something to reach out to communities who are negatively biased around AI. We are working very, very much on AI ethics and making sure that we're building algorithms responsibly. We're also working on educating people. So basically, we've started multiple programs that allow people to get technical education for maybe without a degree for just a few months, right? So it gives them better skills to survive in this changing world. But yeah, the thing is, I think the progress is going to happen anyway, right? So whether people are negatively biased or not, it doesn't really matter. But I do also think that as a community, we're responsible for making sure that we take as much care as possible to build things responsibly. So the question was if AI ethics should be regulated by government, or if I believe that. I don't think so, but I think that, so there's a number of initiatives around that space with a OpenAI letter and treaties that are, starting off as grassroots movements, sort of like open source agreements and stuff like that. I do think that we need to think about this more, and as developers or IT people, we need to invest more time in this. So maybe this is something that comes from us rather than governments.
I'm afraid that is all we have time for at the moment. Are you going to be around?
I am going to be around, and like one more thing. Big kudos to Max Tegmark with Life 3.0. There's a lot of insights and examples in that book and a couple other things. So thank you, guys.